All right, so we are going to be doing the second part of the 3-2 notes now, finishing up those notes, and then you'll want to finish the worksheet after this. This will be collected next Tuesday, Wednesday before fall break, and we'll have a quiz on Wednesday, Thursday next week. Monday and Tuesday's quiz 3-1. So going on, we're doing logarithmic differentiation now. So I believe that says e to the c. Well, c, I think that's a c. A c is a number, so e to the c is just going to be a number. So this would equal 0. Oh, I already told you the answer, and I'm supposed to give you a minute to try these. You guys try the rest of these real quick and see how you do. And then I'm gonna give you about 40 seconds to try to do those on your own. Okay, so I'm going to go ahead with the next one. That was e to the e power. So e to the first is still just a number, so that's 0. E to the pi is also a number, so this is 0. And the next one says x to the e power. Well, if it's x to the e power, that's going to be power rule. So I need to move the e down in front of the x, and then I have to subtract 1 from the power. So that would be the derivative of this one. And now this one's a crazy hard one. So if you look at part D above, it's problematic because the differentiation rules we know. So whenever you have a variable to a variable, and I'm going to give you a hint, you better know how to do this for the test. When you have a problem that looks like this, you're going to let y equal that deal right there. And because we can't really do an x to the x power, we want to get this x out of the top. So to do that, we would take the natural log of both sides. And then what we're allowed to do by natural log rules is we can move that x to in front of the natural log over here. And now we can do a derivative of both sides. So when I do the derivative of natural log of y, that is going to be 1 over y. But I'm doing these derivatives with respect to x, so just like implicit on the previous lesson, I've got to put dy dx with that. Over here, I got to do product rule. So I do first times derivative of the second plus the second times derivative of the first, which is a 1, and there's already a 1 there, so I don't need to change that. So this is going to be dy dx times 1 over y, and then these x's reduce, so this is going to equal 1 plus natural log of y. And we want dy dx, if you look up here, we want to get the derivative of that. So dy dx is, we would have to multiply this y over here. So we got 1 plus natural log of x. Now, we do not want to keep this y here. Do you all remember that up here, we said let y be x over x squared? So the last step in solving this thing is we're going to plug that x to the x power in for that y. And that way, all of my numbers over here are just numbers or x's. So this is the answer we're looking for. And I'm going to tell you again, you better make sure you know how to do that for the test. Okay, the next part says, find the derivative of this. So this is the same story. We got an x to an x power. So we need a natural log each side. We want to get everything in terms of natural logs because we got to get that power out of the top. So we can move this power of 2x to the front. And now we got product rule over here again. So we're going to do the derivative of natural log of y with respect to x. So we're going to put the dy dx here. And then over here, we're doing product rule. So we do first times derivative of the second plus the second times the derivative of the first, which is a 2. And now we're going to multiply this y over, and I'm going to reduce these two x's. So over here, I've got I've got 2 plus 2 natural log of x. I'm going to multiply that y over here. Okay, so we got dy dx equals that. And again, we knew that y equaled this thing right here. So the last thing we're going to do is we're going to plug that x to the 2x back in for y. So dy dx is going to equal x to the 2x times 2 plus 2 natural log of x. And that's good enough for the answer. Let's see, the last page of the 3-2 notes. How could you take a derivative of y to the 2x without using the formula? So this is the exponential formula we use, which is this thing, natural log of the base times the same power. And remember, you take this times the derivative of the exponent. So it'd be times that 1, doesn't change anything. But we could do this exactly the way we did it a minute ago. We can take the natural log of y, and over here we can do the natural log of 2 to the x, and then we can bring that x to the front. And now we can do the derivative of each side. So this is 1 over y, dy dx. And over here you're doing product rules, so it's, I'll put a plus sign there, that's supposed to be an equal. So it's the first times the derivative of the second. I hope you all know natural log of 2 is a number, plus the second times the derivative of the first. So this whole thing over here is natural log of 2. So we multiply that y over and we get y natural log of 2. And then we say y was equal to 2 to the x right here. Y equals 2 to the x. So we stick that 2 to the x back in. And we get the natural log of 2, and we stick that 2 to the x back in. And if you check out this answer compared to the rule, it's the same answer. And we're going to do that again using this formula. And every time they give you a crazy fraction with a bunch of stuff in it, I would always recommend doing the natural log method because it makes it way easier. I'm going to change this radical into a rational exponent and make that a half. I'm going to have to erase this later because we're going to have to substitute it back in for y. But I'm going to do the natural log of both sides again so that I can expand my fractions, or all of my natural log over here using my rules. So we're using the same rules that we used last week on properties of logs. So the properties of logs is when you divide, you take the top one and it's positive, and this 2 is here, but I can also move that 2 to the front. And then I get a minus because the denominator is a minus, and I got natural log of this x squared plus 1 to the half. But I can take that half and move it to the front. And now I can do the derivative of each part, and it's way less cumbersome than doing quotient rule. Now, if you do quotient rule, you get the same thing. So we get 1 over y dy dx. That is my coefficient. So it's a 2, which is going to go on top. And remember, you put the thing after natural log in the bottom, then the derivative of this is 1. So it's 2 times 1, which is just 2. Then I got minus, I got a 1 in top and this 2 in the bottom. And you remember, you put this in the bottom with the 2. And then that's times the derivative of the x squared, which that's 2x. So I hope you see those 2's reduce. So this is going to be dy dx is going to equal, and I'm going to multiply this y over here. I got this 2 over x minus 2 minus x over x squared plus 1. And then last, we're going to stick this crazy radical stuff, this whole thing back in for this y right here. And we'll be done. So when I do that, I get dy dx is going to equal x minus 2 squared over the square root of x squared plus 1 times all this other stuff that was in the brackets already. And we're done. That'll probably be the way they would write that on a multiple choice question on the AP test. So I hope you have a good day and finish up your 3-2 worksheet. We'll be quizzing over 3-2 next Wednesday, Thursday. And again, we're quizzing over 3-1 on Monday and Tuesday. I will talk to you later.